Hey guys, welcome back to Matthews Ballistics. Today, it's my birthday. Turned 30 years old today. So, celebrating that. But last weekend, I went out and did some shooting. I took the 454 Casull, the Browning 1885 out, and I just shot some lead cast rounds out of it because I wanted to see how they performed uh, using some different ballistic data. Uh, and Then I also took out the 338 Lapua because I'm still working out some problems with it, and I think I've got it about lined out. The target I'll show you on that one probably doesn't look like it's very lined out at all, but I think I've kind of figured out what the problem was. But for the biggest part, I took the little Ruger American Ranch 5.56 out with the 16-inch barrel, and I took it and I've got a load developed for it that I really like with a 50 grain VMAX, and we shot that quite a bit. Recorded some specific velocity average for it, and then I plugged it into a ballistic calculator with a little more in-depth information like temperature and altitude and that sort of thing, and then from there I calculated it out to 300 yards, adjust the scope, and it was perfect, dead on the money, what I needed to do with the scope to get it to 300 yards. And that's what I've been kind of experimenting with is the more precise you can get your input data into your ballistic calculator, the more precise your data is, the better your result is going to be as far as accuracy. So, accuracy is being able to hit the target. Precision is repeatability. Precision is like being able to hit the target exactly in the same spot every time. Accuracy is hitting the target where you want to hit it at. So, with that being said, we're gonna go ahead and get this 338 Lapua target out of the way. I am here. Move that. Yeah, I'm sitting out here. It's 3 o'clock in the afternoon. I'm having a couple of mimosas while I'm doing this. It's my birthday, man. Leave me alone. All right. So I kept playing with it, and I was about done because this is after I actually swapped scopes. So what I found out was the Vortex scope is not bad at all. I don't have a reason or need to send it back to Vortex. It's actually still a good scope, and I've just got an ammunition problem. So we ruled everything out. It's an ammo problem. That's all it comes down to, is an ammo problem. And there may be one other problem I'm about to get into here in a second. But anyways, so I'm shooting, and everything's kind of jumping around, and when I thought I was starting to see a group here, it moved with 2 rounds back to back hitting here, and then the next one hit somewhere else. I didn't keep track of it. I just kept shooting it to see if it was ever gonna see what was gonna happen. And what I noticed was towards the end of my shooting, it actually started drawing in on the actual bullseye, and I was pretty happy to see that start. The group started getting tighter. Like the last few shots were all these here. They're not quite tight like I need them to be or like I want them to be, but which led me to the concern that I did clean this rifle and I may have overcleaned it, which is a terrible thing to do to a long-range gun. Because they need a certain amount of copper fouling. It's extremely important to maintain your accuracy and precision, and both those terms go hand in hand. You really can't use one without the other. You need both of them working together to produce good results. So accuracy wise, am I hitting the target? Yeah, I hit the target every round. Precision wise, am I putting the rounds in the same place on the target? No. I've got accuracy, but I've got no precision here. So but I think that I removed too much copper fouling from the barrel, and with that being said, it's going to take maybe another 30 to 50 shots to get enough copper fouling built back up in the barrel at this point to get it back to where it needs to be, which is, kind of a little bit of a headache. It's kind of a little bit of, man, can't believe I did that, and now I'm spending a lot of money to get it back to where it needs to be. Because I mean, when you're thinking about it, you're like, oh man, there's 100 grains of powder in there or more, and then a bullet that probably costs a couple dollars sometimes. The Hornady ELDMs, I think I'm running those at about 80 cents a piece, and then the powder I'm running 104 to 106 grains of this USA 69. So I mean, it's about 60 cents worth of powder, give or take, based on what I paid for it. So reloading it and all with the primer and everything factored in, I'm reloading my 338 Lapua for a little under $2 a round, just a hair under $2 a round, and which is going to get more expensive because my brass is now like on its third, I think, going on its fourth firing of reloading. So at some point soon, I expect between 5 and 7 reloads that I'm going to start experiencing brass failure, where it's going to start cracking, and I'm going to have to start tossing it, throwing it away. It's going to get too thin, and I'm going to start having to lose cases, and I'm going to need to replace those. And right now, a really good, clean new brass is running about $3 a piece or so for like some Lapua brass. If I want to go with Peterson, it's almost about $4, about $3.80 a piece. And I'm thinking about going that route with the Peterson brass, just because I've really never used it. I've always just used whatever I can get my hands on, but from what I understand, from what I've heard and been told, the Peterson brass is the best brass you can buy. Whether it is or not, I don't know. I guess it really comes down to your application. Anyways, we're going to move on to the 5.56 Ruger American Ranch. I'm not going to mess with showing you guys the details of the 454 targets. They were great, as usual. That rifle just shoots so good. Even playing with it out at 300 yards. I will say this, at 300 yards, I'm just a little beyond my adjustment range in the scope using the HSM bear loads, which are very low velocity. We're talking like 1450 feet per second out of that rifle. If the velocity was closer to about 2,000 feet per second, I would have no problem hitting it 300 yards. It would be well within the adjustment range, but because they're so much slower muzzle velocity wise, and they lose so much speed so fast, they drop a lot and drop well beyond my scope's capability of adjustment. So that being said, we're going to get into some 5.56 NATO. These rounds, this is a 100-yard target. Yeah, I'm still in selfie mode. I like filming that way because I make sure that you guys get to see everything I'm looking at. So anyways, I messed around with it a little bit with the Arken scope, and this is a load that I developed. This is shooting a 50 grain VMAX, and I'm loading it over 28.5 grains of CFE 223, and that's the maximum load. That's the max book load for this. I changed the bolt seating depth a little bit, and I'm, out of my 16.5 inch barrel on the Ruger American Ranch, I'm getting chronographing right at, it's 3,052, I think is what I averaged over 20 shots recording on a chronograph, which is a pretty good size sample of recording. So 3,052 is going to be my average. I did get a couple shots that were well into the 3100s, and I think the problem with that was this brass is all brand new. It's brand new Lake City brass, but when I measured the length, the OAL on the brass, it varied and had a span, an extreme spread in length of about 5/1000ths of an inch. So I didn't really think too much of it because I'm like, this is just a fun gun. I'm not going to shoot it much more than 300 yards. But it makes a difference. Everything needs if you want precision and want everything to hit in the exact same spot every single time, you're going to have to trim everything exactly the same as far as your brass goes. And it may even be important to, like, in longer range circumstances beyond 300 yards, it may be important to actually turn the necks of your brass to ensure the neck tension's exactly the same every time. But I'm not really worried about that right now with this rifle. A lot of people would say at 100 yards it's actually a really good hitting rifle. But with this round, the brass neck tension was a little off round to round, and that being due to the fact that I didn't trim it exactly the same every time. And basically, when I applied the factory crimp dye to it, because the brass was different lengths by a little bit, it applied a little bit more crimp or a little bit less crimp brass to brass, and so the neck tension was always a little bit different. Had I not crimped it, I would have still had the same problem. Just the result might have varied a little bit. The velocity I recorded might be a little bit different. Like, it might be up 10 or 15 feet per second, or it might have been down 10 or 15 feet per second because I didn't crimp it, but I would still have the extreme spread that I got, which was, I think the extreme spread over 20 shots was pretty high. It was at about 100 feet per second, a lot higher than I want it to be. But I was just playing with this, and it was just for fun. So I got my 20 shot group here, and I got it pulled in to where I was hitting where I wanted to. It's still hitting slightly to the right, and then I took it out to 300 yards, and we shot this 20 shot group at 300 yards using the 50 grain VMAX. So you can look at these two targets and tell that they're both pulling the same direction right a little bit, and as far as the spread and stuff, vertically, the velocity started to really matter at 300 yards vertically, with the vertical spread being that your faster bullets, your 100 foot per second higher bullets, are going to hit really high, and then the bullets that hit below your average quite a bit, say my average was 3052, and that's what ideally I would get my zero with, and the ones that were 3100 or 3120 were hitting high, and the ones that were like 2950 or 2980 were hitting low. But what was interesting to see was that once I played around with it, I actually moved horizontally. My spread's not as bad as actually this group is. So, and if you measure out a 3-inch diameter circle, which would be roughly 1 MOA at 300 yards, the majority of the shots are within that size circle on that target. So had I trimmed the brass correctly all the way exactly the same every one of them, I very likely would have had a sub MOA group. Been very easy to shoot under an inch at 100, or under 3 inches at 300. So I wanted to share that with you guys. I know I didn't really get to film any shooting, and I wanted to, but it was just really busy that day at the range last weekend. So moving on from that, I've been watching some Tiborosaurus Rex videos, the guy that does the Rex reviews and stuff. I've been watching his Sniper 101 series and how he sets up his long range kit and stuff. And I know some people think he's really cringy at the way he does things, and think that he may be full of shit, but from my experience shooting and the stuff that I've seen, and then using some of, and actually field testing lately, some, I don't really talk about it, but lately I've been actually field testing some of his concepts and theories in shooting, and just from 100 to 300 yards, some of the stuff he has to say really works, and it really makes a difference. So I've been playing with building a couple different charts I think I lost one. No, there it is. A couple different charts based on some of the information I found in his videos, like building a drop chart for my 5.56 and building a muzzle velocity temperature curve, because from my takeaways from his long range videos, and he goes way into detail on these, is that there's two things that really, and my takeaway is that there's two things that really affect your bullet's point of impact, and that is, one is temperature, ammunition temperature, and ambient air temperature. And ideally you want those to be the same when you're shooting and recording your data. And two is the barometric pressure, the altitude you're at. Those two things can have a huge impact in your trajectory at long range, and if you're using a ballistic calculator, it's extremely important that you get those two things entered in correctly, you know. So I went out, and to be able to do that, you know, and I'll get into these charts more in depth in another video, but so I bought a Kestrel, and this is a Kestrel 5000. It's not one of the fancy ones that has the ballistic software. This is one that is just the weather meter, but it has a good feature where it actually measures station pressure, and it also measures barometric pressure, and calculates altitude from that. So if we turn this thing on, we can just look and see where we're at right now. Let's see if we can get some wind here. Alright, so it's saying altitude is 446 feet, which I believe is probably pretty accurate. The altimeter GPS thing in my car says I'm at 420 feet here, I think. But I would trust this over that. And it's saying we're right at 29.43 inches of mercury. Humidity is 76.8%. Right now I've got a dead wind here. I know you can probably hear the wind in the trees, but I think it's at a higher level than I am. A lot of the trees on our property are, I would say, close to 100 feet tall. So they could be 520 feet in altitude, and it makes a difference. Right now, sitting under the shade here, we're at 84.4 degrees Fahrenheit, and it's saying 80.5% humidity. The density, the altitude density right now is 2,590 feet, which is interesting. Anyways, my barometric pressure is 29.4344, so it changes a little. Unfortunately, the wind's not really blowing, so we have no wind sitting right here under the awning. So your barometric pressure and your temperature play a huge role in bullet drop at long range. And that's what your temperature curve is for. Like, this starts at 0 degrees Fahrenheit, goes all the way up to 100 degrees Fahrenheit, and this is just based on muzzle velocity. And you can kind of start this with this thing. This is a kind of a cheat sheet, and I'll try to go more in depth on it, but it's got 3 levels. It's like at 2850, 2900, 2950 feet per second muzzle velocity. And then you've got a temperature scale on the side, and you get your baseline. Well, on this one, the baseline's set at 70 degrees, and you, if you go to 80 degrees, you got to add 29 or 30 feet per second to it. If you go to 60 degrees, you got to subtract 23 to 24 feet per second from it. And those things change and get the variation gets bigger the higher the temperature is, or the lower the temperature is. Based on that is how I get this curve here, because I shot this data at 80 degrees, and so my muzzle velocity at 80 degrees was averaging 3,053 feet per second. And so from there I subtract what I need to do, and I've got a deal over here that tells me, okay, at 80 we're going to subtract 30 feet per second from it to get our 70 degree average, and then so on. And so basically this works to an extent, and it works well, but you really need to be able to test it. And ideally you would go out, like say I did the testing at 80 degrees to get my muzzle velocity, and then did all the calculations based on that, from 100 degrees down to 0. Ideally I would go to like 20 degrees lower, go to 60 degree weather, go out, make sure it's 60 degrees outside, shoot again, and try to confirm that this calculation that says it should be 2,999 feet per second, I need to confirm that I'm actually observing that. And then, if I can observe that at one other temperature, either 20 degrees hotter or 20 degrees colder, likely the calculations are going to be correct, or pretty correct, for the rest of this chart. But this is only for one bullet in one rifle. This is my Ruger American Ranch 5.56 50 grain VMAX, 28.5 grains of CFE 223. If any of those things change, you put it in a different rifle with a different length barrel, you're going to have to start over. You're going to have to make a new chart based on this. And then use that chart, and you input the variables, and you come up with your drop chart based on your MOA on the temperature, because different and use JBM ballistics for this is what Rex used, and that's what I'm using too, because it works pretty well. It's a website that's been around for a long time. So if you use that and you input your data correctly see, this was at 29.92 inches of mercury is where I factored in that. That's because we were at an altitude of 520 or 540 feet at the range that I shoot at. That's the altitude of it. So it's going to change a little bit depending on your location, especially if you live in a mountain area. But with higher velocity, higher muzzle velocity based on higher temperature, your range can actually be extended, your effective range. Rex uses his effective range max at the maximum range that the bullet will fly supersonically. So once it goes transonic or subsonic, he considers that the cutoff. Now with newer bullet technology, the transonic, subsonic zones are not nearly as hard to shoot past as they used to be, I don't think, and people are getting better at being able to account for that difference in pressure in front of the bullet, as far as shooting really, really long range. And I think Mark and Sam After Work, a couple on YouTube that shoot down in Australia, they do a really good job of their calculations and being able to shoot 3,000, 4,000, even 5,000 yards, which is insane. I could only dream of being able to shoot 5,000 yards, let alone even 3,000 yards. I've never actually had an opportunity to even consider shooting that far. So we've got our weather reader, and it can be used, and it definitely collects accurate data. That's the whole point of having one. This one doesn't have the ballistic software, so it's about $250, give or take. Not real expensive for the value. If shooting really long range is going to be your thing, you're going to need it at minimum this one. Some of the other ones, the Kestrel, like 5700 or 5700 Elite, that comes with the applied ballistic software already in it, so all you have to do is input your muzzle velocity, and it basically will do the rest for you. That's a different level of stuff, and those ballistic instruments start probably in the $600 range, and go upwards of $800, give or take. Besides that, ammo temperature is extremely important, and basically this whole chart works, and this chart works, and stuff, all this stuff works based off of your ammo temperature matching your ambient air temperature. Is the easiest way to make that stuff work accurately. So at Walmart you can get you one of these. It's a laser thermometer. You can check your actual ammo temp and compare it to the ambient air temperature, and you know, there's some things you can do there to help that chart out and make it more precise, or these charts more precise. And this is like a $20 thing. One other thing that Rex recommends in his long range kit, in his drag bag, is a tool set for, you know, adjusting your scope, or if you have to dismount your scope and remount it. This thing at Walmart, I think, is about $10, maybe 11 or 12 bucks, but it has the Torx bits and stuff that will work on most of my scope mounts, and then it's got a couple other bits in there as well. And the last thing I'm going to talk about is a spotting scope, and I think the main purpose for long range shooting you'd want a spotting scope for is, one, yes, spotting your round where it hits, but if you've got a really nice decently powered scope on your rifle, you should be able to use your rifle scope to spot your round. But with the spotting scope being able to go up to like 60 power or so, 20 to 60 power, you can be able to read mirage better at long range and be able to read the actual wind speed based on the mirage at different distances. This is something I don't really know anything about. I've never tried to read mirage, and it's probably going to take quite a bit of practice and some research and learning how to do it, but I finally decided to get me a decent, I say decent, comes with a tripod, but this is an Athlon Optics spotting scope, and this is a 20 to 60 power. It's the Athlon Talos 20 to 60 power 80 millimeter objective lens, and it's clear enough. It's surprisingly clear, actually. At 300 yards you can actually see 22 caliber holes in the target, so you'd be able to spot your holes and be able to say, hey, you're shooting about an inch higher, so you'll be able to see them pretty well at 300 yards, which is good, because with your bigger rifles, like anything that's, you know, 30 caliber or 338 caliber, or even, you know, or even 6.5 millimeter or 264 caliber, on up into the 50 cal range, you'll be able to spot those holes at even farther distances. But the main reason to have a spotting scope is to be able to read the mirage and be able to calculate your wind speed based off of that. Ideally, you would have a spotting scope with a ranging reticle in it. This does not have that. Did not pay near enough money for it, for one to have that. That scope was actually $199 on Midway, and they were having a sale on them, and they were selling them for like $119. So I was like, I'm just gonna buy one. I don't have a spotting scope at all, so I'm just gonna buy this one, and you know, it'll do the job for what I need it to do. But yeah, the ones that actually have the ranging reticle, where you can actually see the bends and the heat waves and see how far they're bending on that reticle, would be much more handy to have, to be able to calculate, say, okay, it's been bending to this point at this value, it's going this speed at this distance, that sort of thing. Not having a ranging reticle in it, you really don't have that luxury of being able to do it that way. You would just have to get used to seeing it, and just kind of know what you're looking at, know it by feel, you know, more or less. So because it's important to have your wind speed where you are, and that's basically where this is limited to, is it's only going to give you wind speed at the shooting position. It's not going to give you wind speed at the target or halfway to the target. And if you're shooting really long range, those wind speeds at different distances change. You know, you could have a wind coming through here at 500 yards and then going back there at 700 yards and then going back this direction at 1,000 or 1,200 yards, and you're not going to be able to get that information from this. This is only going to help you out at the shooting position. and the further you get out, the further off the information it's giving you is going to be as far as your ballistic calculator goes. So, anyways, I just wanted to give y'all guys a heads up. Didn't mean to ghost y'all for a week and not give you a video or any sort of update. It's just been kind of hectic with my birthday coming up this week, and then out of nowhere up at work, they took a vehicle in on trade, because I work at a dealership, and they took a vehicle in on trade that I pretty much had to have, which, by the way, if anybody's looking for a twin turbo diesel 335 sedan BMW, I've got one for sale. It's already got all the emissions junk taken off of it, deleted, it's been tuned, and I've driven it every day and put about 30,000 miles on it, a little over 30,000 miles on it since I bought it, and it's been a daily driver. I don't have anything else to say about it. It's a good car, and it's very fun to drive. It's tuned up, but I've got one for sale. So yeah. Other than that, this is just what I kind of wanted to go over, and what I wanted to get into is coming up with some ballistic charts. These charts actually haven't been tested yet, so I'm curious as to how good the information that Rex is putting on his YouTube channel almost 10 years ago now, and he did this video series back in 2013. I'm curious as to how good that information is today, so I'm gonna put it to the test. We're gonna see how good it is. Of course, I've only got a range going out to 300 yards currently. The guy that's supposed to be helping me get out further, that has access to a place to shoot further, is, he's a busy dude like me, works all the time, so it's kind of hard to sync up our schedules and actually get to go do anything, but we have been talking about it a lot. Like I said, he's got a 300 PRCs wanting to stretch out, and as soon as I get this 338 Lapua lined out, I really need to stretch it out too, and start doing some of these charts for it. So, with that being said, I hope you guys have a great rest of your weekend. I am planning on going and shooting Monday since we're off work, but being that it's a holiday weekend and everybody's got Monday off work for Labor Day, I'm betting that the gun range is probably going to be too busy to be filming on, or hopefully everybody's at the lake with their family and I can have a nice quiet range to shoot on. One can hope. So anyways, I hope you guys have a great holiday, great Labor Day weekend, and we'll see you next time. It's been Matthew's